Okay, so simplifying user interface programming.
Whoa.
This is going to be the psychedelic version. My favorite type of programming is console applications. Does anybody else enjoy writing console applications? Okay, there's a simplicity and a purity and a beauty to the console application where you have like an input and you have an output, and your bit is to fill in what goes on in the middle. So that's my favorite type of programming. User interface programming is the opposite of that in both ways, in that instead of being my favorite, it's the one that I hate the most. And instead of being the simplest, the purest, and the most beautiful, it's the one that's the most horrendous and terrible, and everyone should feel bad about ever doing it. Before I get too much further into ranting, this is where I currently work, and we're hiring JavaScript programmers. We have our server application built in Node and client-side stuff obviously in JavaScript, and growing really quickly and having a lot of fun time building a community. So the problem is that 48% of the code that we write, 50% of the time that we spend coding, and 99% of the headache that we experience during our day-to-day activities is user interface programming. Okay, so it's a huge part of what we do. These stats that's 92, that's a long time ago. I would think that if anything, UI stuff has become more prevalent and a bigger issue, and therefore a bigger problem. So because this is the shorter version of an hour-long talk, I'm skipping straight to the solution. What I think is the solution, which is this MVI design pattern for user interfaces. Basically stolen from an article called the Elm Architecture, which I continue to highly recommend, in that it will give a more coherent and complete explanation of why this is a good idea. But in a nutshell, we have these three components in our user interface. The model is a single piece of data that contains everything you need to describe the user interface of your application. The view is something that can convert that single piece of data into the current representation of your UI. So if we're talking about in a JavaScript context, our model would be a JavaScript object. Our view would more than likely be a function from that JavaScript object. So that's the input to the function, and the output of the function being some HTML, some chunk of DOM. Intents then are the things that the user does, or the things that the user is trying to do. To take the classic to-do list application, the intent might be to add something to my list. That would be one possible intent. Another possible intent would be to mark a thing off as being completed. And the cycle that we're trying to show here is that when the user says, I want to add an item to my list, that then becomes a change to the model. So we add a new item into the model, which then can trigger our view to produce a new representation because the underlying data's changed, which goes back to the user. Now they see the new item in the list. Now they decide that they want to do another intent, and hence we get that cycle going. Okay, what are we looking at?
Pong.
Pong, the classic computer game that so many misspent youths went into Pong here. Just in case you've never had the pleasure, there's a ball that goes backwards and forwards, and then there's a paddle. One's controlled by the computer more than likely, and the other's controlled by the user. You move up and down and try to. It's like that air hockey. It's like that. Yeah. That's Pong. Okay. So imagine you're trying to create Pong in that MVI architecture. So always a good idea to start with your data model. What data model do I need to describe this user interface? What kind of things am I going to have in my objects?
Paddles.
Paddles? Well, where the paddles are, you would need to know. Yeah. Maybe how many of them if that is ever other than 2.
How fast the paddles move when you're...
Sure, yep. Score, cool.
Collision detection.
So that's part of your implementation, it's not part of the model.
Oh, yeah.
The vector of ball.
The vector of the ball, yeah. So, and the location. So location, direction, and speed of the ball is the other big thing that you need to know. Okay. All right. Let me find this on my computer again. I see what the problem is. See, the window's too big to go. Oh no, wait, I'm sharing screens now, aren't I? Yeah. Sorry. Okay. So here's an initial attempt at implementing the game of Pong. On my screen, this is black, but here you get like the AstroTurf version.
This is a tennis court.
It's a tennis court, sure, yeah, right. Once again, the place to start is by looking at the state that we need to produce this particular user interface. And I'm starting with Pong without the scores and without the ball, so all we have is the left position offset paddle, or the left paddle position offset, which is the distance from the top of the screen to the paddle, and the offset of the right paddle as well. That's our state, okay? Now, in MVI, once we've got our model, the next thing we need is a function that can convert that model into our user interface that we're after. So here I'm using React, which maps this paradigm nicely because React is built out of components, and a component just so happens to be a function that goes from your model that represents your UI to a piece of DOM, okay? So I have at the top level a function or component called game. The input is that state with the left offset and the right offset, and the output is this bit of DOM here. So we've got a div, I've got to draw the net, and then we have 2 components which are paddles, one which is set to be the left paddle, one which is set to be the right paddle, and they're given their offset in the state. So hopefully already you can begin to see that cycle forming, that if we then go and change the values in that model state and rerun this function, the paddles will move up and down. So because the paddles are themselves components, they're also a function. Instead of taking like that full state of the entire application, they're just receiving their actual offset, which is and the side. So those 2 values. So based on the side property, they're either all the way to the left or 800 pixels to the right, and then their offset from the top is set to the value that we passed in. Okay, so being React, the last thing we then have to do is just tell it to render that game component with our initial state. So this is sort of a static version. It's M and V, but I haven't got around to putting the I part in yet. Cool. Okay. Yeah. So that's the state and the view, or the model and the view. To then get like something interactive happening, we have to add in the intents. And the intents are things that an actor in our universe can do that may potentially cause a change to that state. All right, so my state is still keeping it nice and simple, just the left and the right offset. Now if I select my Pong game and use the up and the down arrows, I can have a little bit of gameplay there. It's quite fun already. And to make that work, I've created a game loop just using set interval at 20 millisecond timers. So React is continually re-rendering the application, which is that process of pushing state through the view to get an updated visual representation. So then if I have a way of changing the state, you'll see the game change. Okay? The game and the paddle components are unchanged here, but all I've done is add some event handlers to the up and the down buttons. When you click the up button, we modify the left paddle offset of state by 25 pixels. We reduce the offset by 25 pixels, so the up button makes the paddle go up. And conversely, with the down handler, we move the paddle down by 25 pixels. Because we've changed the state and because that game loop is running, magic happens, okay? All right. So that's pretty cool, and that's really MVI as far as I can possibly boil it down. If we were to expand that out into like Gmail or Trello or whatever it is that you guys work on, you'd probably find that it's a little bit overly simplistic, and having random event handlers modifying your global application state could get a little bit out of hand. So enter Redux. Yeah. Interestingly, importing PowerPoint into Google Slides thing is terrible. So Redux is a library for React that adds a little bit of design around how we manage that model and how we control who can make changes to it and what changes they can make. So what we're trying to do is to centralize our UI state, make sure we have a single object that contains the complete state of our UI. So you could, if you wanted to, do things like write that object into local storage and then come back a month later, read it out, and boot the application right back to where you were. We also want to control the way in which that state can be mutated, and Josh showed the immutable JS, and that's something that works really, really well with this, and Redux does indeed encourage you to make that model object immutable effectively for some performance reasons, but I think it does also give you some nice characteristics in terms of the ways in which you can reason about what your state mutations are doing. And finally, the thing that appeals to me about this is what we're trying to do is keep things simple, okay? So after many years of being a programmer and continually overestimating my capabilities, I come to the conclusion that the way to be good at programming is to make things easy for yourself. Find a way to have a design and an architecture where like you don't have to keep a billion things in your head at any one time. You don't have to solve problems by trial and error. You don't need a debugger. You just make it simple enough that you can just do it and get it right and get on with life. And things like Redux and MVI help me to do that. So how does Redux do this? For some reason, it's hidden the answer to my how question. So Redux provides lots of stuff that is very confusing to people trying to learn it, but there are three functions that matter. One is, I believe, called create store, and what that does is create a wrapper around your model objects for your application.
Get state.
Get state, yeah. So the get state is definitely an important function in there as well. So that's basically how you, from that store that you've created with Redux, how you get your application state back out. And the other one is where you tell it how to make a change. Dispatch, thank you. You guys should do this. So yeah, dispatch is how you send an intent to Redux and say, apply this change to your internal representation of the UI state. Okay, so the final step in our Pong Odyssey is to add Redux in for state management. So this gives us something that's a little bit more scalable to a real application. It's a little bit of a reveal as well, because I did this talk like 2 weeks ago, 3 weeks ago or something, and when I finished I was like, I'm going to finish this Pong game on the train on the way home, okay? So you're going to see how far I actually managed to get in that particular quest. what with my like simplicity and all that sort of shenanigans. Okay, here we go. Yeah, I can go ahead and do that. Just like, here we go. Okay, but the paddles, sweet.
That's the best part of the game, right?
Yeah. Okay, so it's worth noting that the paddle at least doesn't go all the way off the edge of the screen. The scroll doesn't ring. Oh, that's good. That was something. So the game component remains unchanged. The paddle component remains unchanged. I now have a ball component, but that was like my train ride. The state, yeah, still the same from the point of view of the paddle offsets. That I've obviously added in the ball state here, and as the gentleman mentioned, we need to track where the ball is, the direction it's heading in, and how fast it's moving. This is where my bug is, or one of them. Okay, so with Redux, the first thing we have to do is create a store. So that's a wrapper around our model state. The parameter that we give to the store is a thing called a reducer, which is just a function. The reducer is a function that takes the current state of the application and an intent. And in Redux terminology, they call the intents actions. But either way, it's a value that represents something that the user wants to do. They want to move the paddle up, they want to move the paddle down, right? And this is also where we use the default thing to set the initial state of the application. So then within the function, what you need to do is you need to take that current state, you need to take the user's intention, you need to combine them together and produce a new state, okay? So if the user's intention is to move the paddle up, then we modify the state object by reducing the left paddle offset by 25 pixels, just as we did before. They want to go down, we increase the paddle offset by 25 pixels. Math.min and math.max here, that's what keeps us within the bounds. So we only do that so long as the paddle is on the board. I don't really know if it's a board or not. And so now I have like an interesting other intention. And this is where it gets a little bit weird, right? Because normally the intention is the thing that the user wants to do. But really it can be any actor that influences your system. So conceptually here we're saying that time is also playing this game, and time is inputting a intention on a regular cycle, okay? A regular interval. And that's the one that we call tick. And that's what allows us to move the ball, essentially. We say on a regular interval, we recalculate the position, direction, and velocity of the ball. And that's done here with a little bit of trigonometry, but what you don't see is any consideration for edge detection and making the ball turn. It would be fairly simple. It would be much like the paddle. So we would look at those calculated values and whether they're within an acceptable range, and that's going to tell you whether you're hitting the top or the bottom. And when you do, we know the angle of incidence, so we can calculate the other angle, whatever that one's called.
Reflection.
Reflection, thank you. Didn't get around to it. So then the only other change is on our event handlers. Now instead of directly mutating the model state, what we do is we dispatch an intent to Redux, to the Redux store. So like I said, it's a value. By convention, they have a property called type, which tells you what type of intent this is. Often they'll also have data attached. In the case of moving a paddle up and down, there's no data. It's just the type. You want to go up, you want to go down. But like in the to-do example, your type would be, I want to add something to my list, and the data that goes along with it would be the actual item that you want to add. So for the event handlers, we do up and down, and then every second we dispatch that tick intention. And those are the So I guess what we've done is we've reified the 3 different ways in which you can mutate the application state and made it really clear what the inputs and outputs are for that particular transition. So that is the way that I look at user interface design. Not design so much, not visual design, but sort of architectural type design, and how I try to make it nice and simple for myself. So at any point in time, no matter how complicated your application is, the UI that you're looking at is just a straight translation of whatever that application state has to be, and then we just provide very careful rules about how that application state can be modified, and that keeps things nice and simple and within my capabilities. So something to think about. Also, something that works really well in the React type of tooling. You can apply the same ideas with something like Angular, but the tools will tend to work against you more than for you a little bit. So I guess that's kind of where a little bit of my bias comes from. That's it. Thank you.
Are there any questions for Liam? Questions, anyone? Sure.
You've kind of gone halfway there with the Elm architecture. Do you have any plans to actually go to Elm?
I think Elm is really cool. I've looked at it. Like I said, I'm trying to hire at the moment, and as you do, like I created a little programming exercise to get people to do, just to sort of show that they can actually solve a problem. And one of the guys did his solution in Elm, which I thought was really cool. It was pretty rough because he didn't know Elm, but well, I thought good on him for giving it a go.
Yeah.
Did you hire him?
I'm working on it. Yeah.
All right, fantastic.
Okay, thank you.
All right, so the next talk's going to be on Elm.